In this lesson, we'll be exploring dilations as a non-isometry. Now, those are two big words in math. A dilation is a type of transformation, and it's a non-isometry because the image after the dilation will not be congruent to the pre-image. Let's take a look. We see a quadrilateral ABCD. The coordinates of the vertices are given, and we're asked to classify the quadrilateral in as many ways as possible. Well, when we look at this quadrilateral, you may be tempted to say it's a rhombus or it's a square. But how do we know for sure? We use the coordinate plane to help us. So we want to look at the slopes of sides, because if it's a parallelogram, for example, opposite sides will have the same slope. So to find the slope of side AB, we want to measure the rise and the run. The slope of side AB is 2/4 or 1/2. We might want to look at the distance between points, so the length of a side. Side AB, we could use the Pythagorean theorem to find the length of that side. Using a squared plus b squared equals c squared, we could square 2, we could square 4 and add those together and then take the square root. We get the square root of 20 as the length of side AB. We could go right around the figure doing the same thing, finding the slope of the side and the length of the side. So for side BC, the slope is -4/2. Immediately I pause and I notice that that slope is the opposite reciprocal of side AB. Therefore, I know side AB and BC are perpendicular and that angle B is a right angle. That helps me classify the quadrilateral. I also know that the length of side BC is also the square root of 20. So now I can see this might be a square. This might be a rhombus if all 4 sides are congruent. I then go around the figure and I find the slope of those sides, and I'm noticing that in fact this is a parallelogram because the opposite sides have the same slope and are parallel. It's also a rectangle because all 4 angles are right angles. It's a square because all 4 sides are also congruent, and it's a rhombus. Now, number 3 says to dilate this figure using a scale factor of 1.5 and using the origin as the center of dilation. In this lesson, we're going to, if it's being dilated over the origin, we can simply multiply the coordinates of the pre-image by the scale factor to get the coordinates of the image. So A prime, we take the coordinates of A, we multiply the x and the y coordinates by 1.5, and we get the coordinates of A prime as -6, 0. B prime, we're going to multiply the coordinates of B by 1.5, the scale factor, and we get B prime has coordinates 0, 3. C prime, let's multiply those coordinates of point C by 1.5, 3, -3. And D prime, when we multiply the coordinates of D by 1.5, we get -3, -6. We now plot those points, we connect the vertices of the image, and we observe that the image, which is in red, A prime, B prime, C prime, D prime, is larger than the pre-image, and that is because the scale factor is greater than 1. And we will notice that happens with dilations. Now let's take a look at another dilation where the scale factor will be less than 1. Here we have another quadrilateral ABCD. The coordinates of the pre-image points, vertices, are given. And our job is at first to classify this quadrilateral in as many ways as possible. Well, here's what I notice. None of those angles are right angles, so that eliminates square and rectangle. These sides BC and AD are definitely not parallel, so this is not a parallelogram. But sides AB and CD are parallel. So because of that, when you have exactly one pair of parallel sides in a quadrilateral, it's a trapezoid. Direction number 3 is to dilate the figure using a scale factor of 1/2 or 0.5, but this time not over the origin. We're using a different point as the center of dilation with coordinates 3, 2. So it's not as easy as just multiplying the coordinates of the pre-image by the scale factor this time. This time we can use a graphical approach to dilate the pre-image. The graphical approach is let's determine how far over and how far up point A is from that center of dilation. So we count 6 to the left and 2 up. Because I'm dilating with a scale factor of 0.5, I want to go half that distance over, half that distance up. So there is my point A prime. I went 3 over and 1 up. Now I do the same thing for the other points. For point B, I go 6 to the left and 5 up. So I want to go half that distance over, half that distance up. So I want to go 3 over and 2.5 up. And there is my point B prime. For point C, we go 4 to the left and 7 up. So I go half that distance to get the corresponding image of point C after the dilation. 2 to the left, 3.5 up. And finally, point D is just 4 to the left of the center of dilation. So to get the image of point D, I go 2 to the left. And now that I've done that, I connect my vertices of my image. This is quadrilateral A prime, B prime, C prime, D prime, and I want to record the coordinates of the image. Point A prime has coordinates 0, 3. B prime 0, 4.5. C prime is 1, 3.5, and D prime is 1, 2. All right, so now that we've practiced dilating figures with scale factors larger than 1 and less than 1 over the origin and over a point not the origin, we'd love for you to try this problem. Number 1 is just to graph a triangle using those vertices. So you need a sheet of graph paper to try this. Number 2, you're going to dilate the triangle over a point other than the origin. And the scale factor is 3. So when you are finished, your image triangle will have side lengths that are 3 times the length of the corresponding side of the pre-image. Put the video on pause and give it a try. All right, so here's how we graph the triangle ABC. We do point A here, point B is graphed, and point C is graphed. We label those pre-image vertices and we connect the vertices to get this obtuse triangle ABC. The point over which we're dilating the pre-image triangle is -3, -2, and we're using a scale factor of 3. So we measure from the center of dilation how far up, how far over to get to each of these vertices. Let's look at point A first. I go 2 up and 1 over. So I want to triple that distance to find the image vertex A prime. So I want to go, instead of 2 up, 1 over, multiply that by 3, 6 up, 3 over, and there's my point A prime. To get to point B prime, I first measure how far up and over did I go to point B. I went up 3 and over 4, so I'm going to triple that distance. I want to go up 9 and over 12, and there's my point B prime. Almost done, just point C prime is left. To get to point C prime, I had to go down 1 and over 1. So I'm going to triple that move to get to C prime, down 3 and over 3. There's my point C prime. I connect my vertices of my image. I observe that each side of the image is 3 times the length of the corresponding side of the pre-image, and I write my coordinates as A prime 0, 4, B prime is 9, 7, and C prime is 0, -5.